Hi everyone, I'm Curt Frye, and in this movie I'd like to talk about equations. Most Excel formulas you create won't need a visual explanation of what they do. They just need to give you the right answer. Some equations, though, such as the Pythagorean theorem for calculating the length of a hypotenuse of a right triangle, make more sense when they're written out. And in this movie, I will show you how to add a known equation to a worksheet, then show you how to build one on your own. The file that I'm using in Excel workbook called Equations can be downloaded using the download link in the video description below. There are two worksheets, and I've started on the one named Pythagorean theorem, and I have side 1, which is 5, side 2, which is 12, and then in cell B5, I take the square root of side 1 squared plus side 2 squared and get the hypotenuse of 13. So I have 5 times 5 is 25, 12 times 12 is 144, and 13 times 13 is 169, so the relationship is correct. If I go to side 1 and change it to 3, and change side 2 to 4, then I get another well-known Pythagorean triple. The square root of two items squared added together can be a little hard to keep track of. So sometimes, and actually often, if you're just learning how to do this, you will see the formula written out. So for that, I will go to the Insert tab. It's tempting to go to Formulas, but that's not where this is. So I'll go to Insert, and then all the way over on the right, there is Equation. In this case, I'll click its down arrow, and that provides a list of items of well-known equations, such as the area of a circle, the others you see here, and then the Pythagorean theorem. So I'll click that, and it has been entered. It is an object, so I'll click it, and I will increase the font size so it's easier to read. So I've clicked the shape that contains the equation, and then on the Home tab, I will click the Increase Font Size button in the font group, and there we have the equation, and I'll just bring that up a bit. So how's this created? Well, if I click inside, then I see that A is a term by itself, and then 2 is attached to it. And there's a very slightly different colored gray area around the A instead of the 2, and that indicates it's either active or next to be active. So if I press the right arrow key, then I move to the other side of the A, and if I press it again, then I move up to the next element, which has the exponent 2, then move to the right, then move out into the equation where we have the plus sign, and then we move in for the B, up for the exponent of 2, and continue on. And because all of these terms are similar, they all follow the same pattern. So I just press the right arrow key to move to the 2, then I'm at the end, and if I keep pressing, I'm no longer within the equation itself, though I am still within the object. And of course, if I press the left arrow key, I can move back. And when you're done, press Escape or click Away, and you will no longer be editing the equation. There are other more complex equations that you could add. So for example, go back to Insert, up to Equation, click the down arrow, and then I'll click the quadratic formula. So I'll click that, and it's been added, and I'll drag it away. And I won't go through all the elements there, but it's very similar to what we had for the Pythagorean theorem. Now let's build a formula on our own. So I'll switch over to the EOQ worksheet, and this refers to the economic order quantity given information that you see here in columns A and B. And the idea is that if you know information about products that you order from a supplier, such as your setup cost, that is the amount of money each order costs you, then how many items you need a year, and also the cost per item, then you can calculate the most economically efficient order quantity, and that is the EOQ in cell B8. With B8 selected, you can see the function or equation in the formula bar. And actually, I'll double-click B8 so it's a little bit larger. So we have 2 times the setup cost of the quantity 2 times the setup cost, and then multiplied by the rate. And again, that's the number of units per year, divided by the holding cost, and that is the amount that it costs you each year to hold on to a particular piece of inventory. So that includes the cost to store it and everything associated with it. So there is the equation that we're going to use. Now let's write it out using a tool to create an equation like we did for the Pythagorean theorem and the quadratic equation. So I'll press escape, but B8 is still active, and so the formula is here on the formula bar. Now I'll go to the Insert tab of the ribbon again, and then I'll click the main body of the equation button. And that inserts a new equation and also brings up the equation contextual tab of the ribbon. The outside element is a square root, so I'll click the radical button, and we don't need to worry about cube roots or fourth roots or anything like that. So I'll just click the square root, and then here I have a dotted box, and that is where we put the items. We're going to be dividing one quantity by another, so I need to have a fraction. So again, on the equation contextual tab, I'll click fraction, and this is a stacked fraction. It comes down to a matter of style, but in most cases you will want to use a stacked fraction. And here I can multiply the items together and then divide them by my other quantity. So I'll click in the top dotted box. This will be the first term in the division or in the fraction, and it'll be the number 2, then an asterisk for multiplication. And now I have the cost of setup, and I say it is cost of setup because I will have C with a subscript for S. So I'll go back up and click the script button, and I want to have a subscript. So I'll click there. Then I'll click in the first box, type a capital C, and then I'll click the next box, and because it's the setup cost, I will use the subscript S. Then I'll press the right arrow key to move out, and I can now multiply by the rate. So that'll be asterisk again for multiplication, and a capital R for the rate. So there I have 2 multiplied by the setup cost multiplied by the rate, units per year. And then I'll click in the dotted box below, and here I will have the cost of holding. Same thing that we did before with the setup cost. I need to insert a script, so I'll click there. We have a subscript. In the first box we'll have a capital C because it's a type of cost, and then click in the box next to it, and then we have H for the holding cost. And now when I click away, we have our formula. We have the square root of 2 times the holding cost multiplied by the rate divided by, setup cost. So we have 2 times the setup cost multiplied by the rate divided by the holding cost. And if we want, we can go to the left of the radical sign and add EOQ or Q star. So I'll double click there, click to the left, and make sure I'm in the right position. And the abbreviation for EOQ is Q star, so I'll type, I will add a script. So this is a subscript. So I'll have Q, and then the exponent will be an asterisk or star. Then press the right arrow button, type equal, and click away. And there is the complete formula. Creating formulas in Excel and other Office applications is very useful if you're creating a mathematical or engineering text. It's not as powerful or, after experience, as easy to use as something like LaTeX, but it's good to know it's there if you need it. I hope you enjoyed this video, and if you did, please like it and subscribe to my channel.